All right. Next topic is now we move on to application policies. We talked about building the fabric, the routes, tunnels, then extending the same type of fabric into public cloud. So once we have the basic SD-WAN overlay up and running, now it's about building those business type policies, right? What is your application SLA, user roles? How do you want to use the overlay to your own benefit? So first off, how do we identify all the applications? Application awareness is key for the gateway here. So we have a DPI engine that could recognize up to 3,200 applications out of the box. Then we also do first packet classification, because a lot of times we are doing direct internet peel-off or direct internet access. It's very important that once we identify a flow, okay, it is going to a certain application, certain FQDN or destination, we cache that information. So when the subsequent flows come in, they get classified on the first packet itself. So you're not breaking any NAT or anything. Right from the get-go, you're routing that on the best performing path. So we do that as well. The next is API-based discovery for SaaS services. The key example here is Office 365. And they have exposed APIs for us to figure out as they update IP addresses for a certain service. I can figure out, okay, SharePoint in this region has changed their IP address range. I can update my database to say that this IP address belongs to Microsoft Office 365. This is SharePoint. This is Teams, so on and so forth. And I could classify the application traffic very, very rapidly. The last is every enterprise has their own flow of custom applications. We support different models. And we also have aliases. In a lot of cases, when we work with large retail customers with tens of thousands of locations, they have this offset concept. They say this 10th IP address in this subnet is always a printer. This 8th IP address in this subnet is always a point of sale. So you could create custom aliases and say 10.10.x.something or 10.10.10.x, and the x is certain address. So you could actually program it that way, and then later figure out which one is printer, which one is your point of sale, so on and so forth. You can create policies based on all of these mechanisms.
So for those that are doing direct connect, express route, and are taking more specific routes for a lot of popular services. So if you're running stuff in AWS and you just chose to take all routes from AWS across the direct connect link, can you guys override that at a local edge basis and say, like, no, I shouldn't be backhauling that across?
Absolutely. So we could actually override that on the edge gateway and then figure out.
Is there an easy way to manage that? Or is that more route-specific topology?
No, today you have to create custom apps for that. There is no way to figure out who has a private link. Let's say Salesforce is running in AWS as a private SaaS. Mm-hmm. We have no way to figure out unless a customer tells us and create custom apps. Okay. So today it has to be created as a custom app and distributed.
But it is possible?
It is absolutely possible.
Okay.
Yeah. So the next is users. So there are two sides of the coin. One side is about different ways of identifying applications. The other one is users. We talked about that already. ClearPass is a linchpin of all of that. As soon as the user or the device comes on board, we profile the device, we authenticate the users, and identify what type of user it is. And as soon as ClearPass assigns a role for the device, Gateway becomes aware of it. So all of the policies you're building for SD-WAN, whether it's the LAN side or the WAN side or the firewall, now you could simply refer to the user role. You can say employees going to Netflix. Let's say it's a hospitality example, right? We see this more and more in hospitality. And guests staying at the hotel rooms, for them, Netflix is kind of like gold traffic because they pay for the room. And then they actually say all these guest users going to Netflix, it's completely different set of SLA. I want to route it differently. And now you can actually simply write a rule in SD-WAN configuration and say employee going to this app, guest users going to this app. And if it's a hospital scenario, you can say my patients going to this app, so on and so forth. This kind of becomes an indirection layer for all the traffic and users in your network. You're not doing any type of IP address or VLAN-based policies. This is an example of what I just talked about, users and role. A combination of this becomes a traffic profile. You first create a traffic profile, and then attach the traffic profile to an SLA. This is what we call it, the business intent SLA. You're creating a business intent saying, this combination is kind of solving a business use case for it. And then this is traditionally latency loss and jitter. We have a bunch of smart defaults. You don't have to figure out what should be the smart default. And we also have options to kind of evaluate as you set up initial policies. It evolves over time because you just can't have standard set of SLAs for every location in the network, because in some cases the baseline itself is different. As we understand the baseline for the remote site more and more, you could evolve those SLAs as well over time. And lastly, you have path preference. So you may have affinity towards a certain path. Let's say my voice, I'm paying for MPLS. It should stay on MPLS as much as possible. And I want to use the backup only if there is a problem. So you can actually have path preference policies as well. If you don't set up a path preference, that's an optional step. For us, we use whichever path that gives you the SLA. Of course, 4G LTE is a special case. We have a lot of tuning you could do for that. You could completely treat it as a backup, meaning we won't touch your LTE connection unless there is a need for that. You are in a disaster scenario where all of your connections are down. Or in some cases, you could use that as a path of last resort, where you can say only for certain critical application I want to fail over. In many cases, they have a really good deal for LTE connections. They want to use it as an active circuit. So we have customers using 4G LTE as an active circuit as well. It's completely up to users to create a policy of path preference here. And we just want to walk through an example. So when we see the demo, it will become clearer. Here's an example of an SD-WAN fabric. So let's say the user is an employee. That's what we're going to show here. ClearPath profiles that user device as an employee device, and that employee, he or she is making a Zoom call. So we place the Zoom call into the voice traffic profile I just talked about. And from a routing perspective, as you build the fabric, let's say your call server or the destination is across another SD-WAN site. Traditionally, it knows the next stop of that device, and there are 3 different tunnels to reach that, right? Because you have multiple paths here. There's an MPLS tunnel, internet tunnel, LTE tunnel. If you simply follow routing, you have 3 paths to follow. So nobody would actually follow randomly any path. That's where the WAN policy comes in the picture. So you have WAN policies built in. You have specific SLA attached to that profile. Employee going to Zoom. This voice policy, you have 150 milliseconds of latency, maybe 10 milliseconds of jitter. It's up to you to build that profile.
So I've got a question on that,
Sure.
going back to how you're building this. As you set your policies, I've got a client that's moving to an SD-WAN platform, and they've got about 2,000 or 3,000 sites. And they leverage LTE pretty heavily. How do I ensure that if I'm doing data replication and the metrics that are evaluating this suddenly decide that LTE is the best path, that I'm not suddenly dumping, tens of gigs or whatever onto LTE and I get this wonderful bill? How does that work?
Yeah, absolutely. So it goes back to
We're gonna see it in a couple of minutes.
Okay.
You'll see it in the demo.
Okay, so instead of explaining, that's a better idea. We'll show that in terms of how you can eliminate LTE.
When you see it in the system, as you see how the configuration works, it's going to be crystal clear.
Okay.
That's a very valid use case. We'll cover that, yeah. And yeah, in this case, typical logic, as soon as MPLS goes down, and you figure out...
Because I jumped you. DPS selected the MPLS as our preferred path. At some point, something went wrong. MPLS is not compliant anymore. We've steered the session mid-flow to internet. Sorry, back.
No, you're doing a great job. So yeah, he's going to run the demo, so you better explain this. So yeah, MPLS, as soon as we figure out there is a problem, we find that there is an alternate available path, which is giving you that SLA. We find that internet gives you that SLA. It automatically moves the flows. We will show you that even if you're in the middle of a voice or video call, we don't drop anything. It actually moves it mid-flow, so you're not losing traffic just because we're moving the session from one path to another path. We show that, and I think we should explain more on that.
Go back to that slide, because there's a couple of nuances I want to clarify before. So first of all, when this one becomes compliant again, when the MPLS becomes compliant again, what happens? We want to be careful with flapping, so we're going to put it on hold for 3 minutes, but my policy prefers that for a reason, so I'll eventually steer the session back as well. What happens if the session is not initiated in the branch, but it's initiated in the data center? Well, what the heading gateway doesn't know that the branch prefers or seeing a certain latency on the MPLS or the internet or whatever. So what happens is the first packet from this client will just take any of the 3 tunnels we had, any random path, okay? Hits here, hits a client. When we go back, the branch gateway selects one path. From then on, the heading gateway will just stick to that path that the branch gateway selected. If at any point in time the branch gateway decides to steer to a different path, this guy just obeys. Okay, does it make sense?
So all the guardrails are in place. There is no chances of asymmetry in this network. You might be wondering, hey, you're randomly picking a tunnel. What happens? Is there a chance of asymmetry? Just like he explained, absolutely no. Because we are a stateful device on both ends. We ensure whichever path is chosen, we reflect back. And the second thing is we never flap because we have a whole timer and dampening mechanism in place. And the path that comes back has to prove that it's worthy enough for us to consider again. So let's show a demo now.
Yeah. So, Mani, you have to take your phone.
Sure, okay, my phone's,
This is it.
we have Zoom call, why don't you call Ramanan? My phone's there, actually.
No.
Okay, let
you
me
have to
pick.
call me. So we have the policy built as this, I think, answer your question. That's why I wanted to hold.
Okay.
This policy, what we do is when we define a policy, we go to the WAN and iPad steering. We say, for this type of traffic, I'm going to treat it like this. If it meets the SLA, it'll stay in the primary path. If the primary path meets the SLA, here I have just one primary path. I think my default has 2 primary paths, okay? So what happens is, if I have one primary path, one secondary path, and the primary meets the SLA, I put for that traffic, I put all on the first link. If I have 2, I just load balance across the 2 of them. If one stops meeting the SLA at any point in time, it gets dropped, and we only use the other time. If both stop meeting the SLA, we just take whichever one is closer to the thresholds that we set. Okay?
So can you, if I wanted to build in a metering policy, I wanted to say, specifically for LTE, because that's a challenge in a lot of areas, could you build in a policy that looks at the data going through and say, I want this to be in effect so long as, and once I reach this limit, then this is no longer a valid path?
Right, we use utilization as one of the mechanisms as well. You could say, I want this to be 50% utilized for the capacity, or you can say 30% utilized. Beyond that, I don't want to touch it. Or you can say, for this application, this profile, I just can't exceed more than 20% of link capacity as well, overall utilization of that link.
Right, but that would be like throughput, and I'm talking more about, I want to be able to account for the data that I've used. Let's say I've used 50 gig or 100 gig or whatever it is. If I have metered data,
I see.
How do you account for that so that you're not blowing your budget?
We don't do that. What we do is, for every application, we determine which are my options. If there's a heavily bandwidth consuming application, let's say your updates that you were talking about, or your backups, we don't give LTE as an option, and that's it. That if my internet goes bad, tough luck. You'll do the backup whenever the internet is good.
Right.
But that's a brilliant idea. We actually have the data in terms of cumulative usage for that link.
I think there's a lot of customers that are dealing with metered LTE data still and would love to be able to track that and then put that into a policy. Because I had one customer that got just an outrageously large bill because of that very issue, and they're really trying to track and manage that.
Absolutely.
Yeah, so we see that. It did happen to one of our customers as well.
Yeah.
Pretty large one. So what we have done is at least we have the alerting systems in place. So then they can set up alerts when they hit certain thresholds of usage. So at least then they can take proactive steps.
Okay.
But you're right, it's a good idea in terms of, can you actually, say, discard this as a candidate link if it goes above a certain
Right.
usage. That's an interesting concept.
So, before you call me, Manny, the gateway itself is also reporting on how is each one of my policies doing. So, for instance, we're talking about the Unified Communications Policy. It's telling that it prefers internet over LTE. And I can go back in time and look at how the sessions were distributed, how whether they were compliant or not. So I can go back and see, hey, at this point in time, broadband LTE is compliant against the VPN concentrator where I would send the traffic to, and against the PQM service, the path quality monitoring services that is living in our cloud platform that Ramanan referred to at the very beginning. Now,
there's a lot of visibility, as you could see. As much as we want to take all this dynamic policy decisions, the key requirement becomes, can I have visibility in terms of where my flows are going at flow by flow level? And why did you take a specific tunnel, a specific path? Which SLA was out of compliance? And you could go back up to 90 days in time to figure out which flows are going where. You see the session numbers. You can actually go to a session level. We'll show that in the demo as well, to exactly figure out which policy it is hitting, which path it is taking, so on and so forth. Without this, it becomes extremely cumbersome to manage all the dynamic flow selections that we do.
why don't you give me a call and we see it?
Sure.
So I am connected to the corporate network here at Aruba. That's why I was so keen on not initiating the call, because it wouldn't make a lot of sense.
So I'm actually connected to the local branch. It's called Branch Corp. It's beaming in SSID.
Here. Yes. So let me introduce you. This is our branch, Mexico. Why Mexico? I just was thinking about Mexico when I was setting this up. There's the orange cable that is connected to a WAN emulator that I have down there. There's the gray cable that is directly connected to our network here. This is not connected to the corporate network. This is connected to a lab environment that is I have the hub site sitting there in a completely isolated setup. So what we're doing here is he's connecting to this access point, and his call is going to go back to a data center and then into my computer.
So it profiled me and put me into, based on my authentication, into an employee role. So I'm making a Zoom call into a completely different device, which is not in that network. So let's see. Dialing.
Employee.
Okay, you're showing clear pass. Okay.
So Manny's calling me over Zoom. Join with video. Join with computer audio.
Yeah.
Okay, so we're seeing Manny there. Now, we're going to add some latency to the link, both on the up and the down. Apply the changes. You can see that the call doesn't break at any point in time. Manny, move a little bit so that they see it's real. Because you're
Moving as much as I can.
you're very stiff.
All right, see you dance. Make sure it's real.
Here we have added some latency, but what we're going to look at what the system has done to make sure that Manny is working as it should.
Yeah, I have to jump in here. Could you go back to the screen, please?
First of all, I'm getting alerts.
Could you go back to the screen real quick, the central screen?
Yes.
So again, though we were talking about WAN policies and how we are doing WAN selection, this is absolutely critical, the differentiation here. Now, since we are troubleshooting a specific client who is an employee role, we show the end-to-end path all the way from the point the client joins the network, into which SSID, which AP, which switch, which gateway, which is the SD-WAN device, from there on which tunnels. The visibility doesn't start for us from the WAN out. It starts from the point the client joins the network into which path it is taking. Really, really important to note.
And you got a new employee who's hacked in.
That's true. Thank you.
So the first thing we see is that the Aruba Central has sent us a Slack notification saying, hey, there's a latency. Please check this. Okay, it's this latency of 500 milliseconds. 501, that one is from here to there. And please take a look at it. We can go and see what happened with Manny. We can see the sessions not on the AP because we're just tunneling everything. We're going to focus on Zoom. And let's look at the traffic. We can see that this session is old. The session table is not updating fast enough.
Okay, show one of the Zoom sessions. You can explain the concept.
Yeah. So here we're showing the session table associated to this device. I clicked on Manny, and I have this tab here. So it shows me where his traffic is going, what exactly it's doing. It has a little bit of delay, so until it pops up, we're going to see him still on the other circuit. But he's definitely steered because he wouldn't be talking with such good latency and so on. We can do further measures to make sure that he steers. Oh no, look, we already see that it's being steered from gig 003, orange cable, to gig 003 to gray cable. If you want to peek in, the orange cable is definitely the one that's plugged into the
WAN emulator.
The WAN emulator. The Slack was telling me fast internet, which is my orange cable, is the one that's here. So let's look at the call. We have Manny there. Without any impact on the user, we have moved the session to the other link. Now, things could go even worse than that. And someone can say, okay, what if it's not just a brownout where you have some buffering on the application and so on? What if someone goes crazy and just does something like this? Well, we see that Manny freezes a little bit. We added a full second of latency, but the session keeps going.
I'm still moving around.
Yeah. Now we see you with a little more delay, but we still see you because between a link with 500 milliseconds of latency and no link, we prefer 500 milliseconds of latency.
So I have a question specifically around this use case because I do a lot of work in Latin America, and they're very, very interesting use case as it's architected on the internet because to move from one Latin American country to another, you often have to go through Miami, which introduces a lot of latency. In this solution, internet exchanges are becoming very, very popular in South America. If I wanted to have an intermediate hop that had a better direct route if I'm coming back to North America or coming somewhere else, could I have an intermediate SD-WAN gateway so that rather than letting the internet take the best path, I could steer it to that point, which would then hit a gateway, so that if I don't want to have 160 milliseconds because I'm going from Venezuela to Brazil via Napa, the Americas, and Miami, I can put it in an internet exchange and hit that point, because that's a real challenge in Latin America.
No, absolutely. We call that a hierarchical model. In fact, we had a customer in Sao Paulo. They had a branch. They wanted to exactly do that.
Yeah.
We put a local header in Latin America, and then we actually build SD-WAN fabric to that. From there on, it's another layer of SD-WAN fabric as well. So you could bypass the internet.
So you can kind of architect your own path as you put these out to help overcome those kinds of challenges.
Exactly. You got it.
Yes.
We have customers doing that in real life.
Yeah, that's actually a U.S. customer. Their data center is in
Louisiana,
in the south, but they have several sites in Brazil. They have the hub site. I'm sorry, Manny, it's in Rio, not in Sao Paulo.
Okay. He knows them better, yeah.
They have this, so any traffic within Brazil goes through their hub site in Rio. If it has to go anywhere, it just goes to the data center in Louisiana.
Okay.
Does it make sense?
Yep, absolutely.
The orchestra really helps in that sense, because you say you set a higher DC, for the branches in Brazil. You set a higher DC preference for the hub in Rio, but because the hub in Rio is not going to advertise your data center networks unless you do a hub mesh, then for the other paths you just take the normal route going to your data center. Does that make sense?
Yeah, very cool.
Very good.
Move on. Any other questions about the?
Yeah, one clarifying point here is, even though we showed one of the examples, which is the path steering, the policy container, which is a combination of user role and application, could be used for any type of policies, right? We can actually have layer 7 application policy, but customers said, streaming for employees, I don't want my WAN circuit to take more than 2 megabits, 5 megabits. And going to certain type of other services, downloading, backup, software updates from employees, I want to assign only certain amount of bandwidth. You can go as granular as you want, put it as a common policy for all of your corporate, it gets pushed down to everybody. So you could actually use this container as a policy object for any type of policies you want.